Hey everybody, this is Joe Zagovich here. I wanted to talk to you today about regenerative braking and how does it work. Now, on electric vehicles and hybrids, the electric motor can recover energy by switching to a generator, and that generator then can supply voltage to your batteries to charge them, while at the same time slowing the vehicle down by having no moving parts. Now, if you need to, you can apply the friction brakes and slow the car down at a more rapid rate, or in an emergency, for example. In that case, you lose that energy to friction heat. That energy converts into heat that is lost. However, on an electric vehicle, that energy is recovered through that generator and charges your battery. So in the next few slides, I'm going to show you how that particular system works and shows you how the lack of moving parts will save you wear and tear and maintenance costs, plus improve the efficiency and safety of your vehicle.
Okay, everybody, now we're going to show you an overview of an electric vehicle. The color codes that we're going to use for a state of rest in an electric vehicle is blue. We'll use the color yellow to indicate discharging, and we'll use the color green to indicate regenerative braking. A couple things to note. When an electric vehicle is at rest, it is not using any energy for its motive force. It is simply using energy for ancillary functions like radios, maps, air conditioning, heating. Unlike an internal combustion engine vehicle, where when you're at idle conditions, you are consuming energy in order to keep the engine running. This is a horrible waste and it produces a lot of emissions needlessly. This would be a perfect feature for service vehicles like police cars, ambulances, or fire trucks or dump trucks, where they're at idle for long periods of time and therefore they wouldn't consume a lot of energy. First, we have the battery, usually hidden underneath the center of the car. We have the motor, and we have an accelerator pedal, which we'll use to accelerate and decelerate. Okay, now we're going to accelerate by pushing on the accelerator pedal. This action will proportionally send voltage and current from the battery to the motors. The electric motors in this case will now receive the voltage and the current for both the aft motor and the forward motor. This will then drive the vehicle instantaneously, no lag. Now to demonstrate regenerative braking. The first action will be to take our foot and remove pressure on the accelerator pedal. The upward movement of the accelerator pedal will cause the motor to turn into a generator. This will create voltage that will then charge the batteries and also slow the vehicle down and can be regulated. This regulation can be useful when you're approaching a stoplight. Therefore, you're not needing the use of the friction brakes until you make the last stop at about 5 miles per hour.
Okay, now that you've gotten to see the slides on how the system works, now what I'd like to do is show you a video of how my electric car shows discharging of the battery, meaning it's a motor, and then regenerative braking by turning into a generator. Okay, so here you go.
Here's an example of me discharging the battery, creating the motive force forward, and now regenning. And I'm regulating that regen because there's a stoplight ahead of me. And as you can see, the amount of regen or green indication is varying for me to slow the rate of the vehicle down so that when I do come to the traffic light, I only need to apply the mechanical brakes when I get to about 5 miles an hour. And there I am applying the mechanical brakes, so less wear and tear. Green light, go! Some additional notes. On a recent trip to Atlanta, I needed to go through Chattanooga. I went through the mountainous terrain, and on the downside, I actually gained 2% by using regenerative braking. I actually gained 2%. This is impossible in an internal combustion engine vehicle. On an internal combustion engine vehicle, your engine is still running, and you have to use the mechanical brakes, which is going to take that friction brake, turn it into heat, and that heat energy is lost. Way to go, Tesla.
All right, now that you've gotten an overview of how regenerative braking works, now I want to talk to you about efficiency. just to give you a comparison. Now, my vehicle, Model S Tesla, would be about 15 miles per gallon in a gasoline car, if it was a gasoline car. However, my electric vehicle with regenerative braking and really efficient vehicle, now we're talking 112 miles per gallon equivalent. 112 versus 15. I do not sacrifice safety. I do not sacrifice performance. I do not sacrifice handling. Everything is a win. So moving to an electric vehicle, you can save tons of money on energy, one, improve your safety and performance. And there's nothing like driving an electric vehicle. Instantaneous torque, boom, you get to be where you want to be at the second you think it. So with that, folks, I'm going to say goodbye and off to the next video where I'll talk about more about electric vehicles and energy efficiency. Take care.